Welcome everyone to the second session of the 13th week, and today I'll start with the second worksheet that has some definite integrals to solve. Now to solve these definite integrals we need to know some integral rules. Now they are somewhat similar to the derivative rules that we have learned before. Now for example, we know that the derivative of ln x with respect to x is 1 over x. This is a standard rule. And similar to these standard derivative rules, we have a separate set of integral rules. And I'll do an example. For example, we have the integral of 1 over x with respect to x is equal to ln mod x plus c. So this is a standard integral rule, right? Now say if we are to compute this standard integral, the definite integral, when you have two limits to endpoints, when they have mentioned two endpoints, we call it a definite integral, right? And if we are to compute this one, what we can do is we can first take the constant out from the integral sign, right? And then you will have this as the answer, right? This as the integral term, right? And now we have the standard integral rule, which gives us that the integral of this one will be equal to ln x plus c, right? And that can be written as ln mod x, don't forget to put mod x, plus c. But here we have, now in this standard notation you did not have any upper limit, like these two limits are not mentioned here. This is not a definite integral, right? But in this case they have mentioned the two limits, the lower limit and the upper limit, right? That means we should evaluate this antiderivative of this one across these two values, right? So how are we going to evaluate that one? When you have a function, let's name it as gx, to be evaluated at these 2 points, I'll name this whole thing as gx. And if we need to evaluate at these 2 points, we have gb minus ga, right? So in that sense, what we have is 1 over 4 multiplied by this one evaluated at the upper endpoint e. That's ln e plus c, because this is our gx. So when x is changed, this point will change, and since this is a constant, it will remain the same. And minus ln 1 minus c. Now here you should have there's an important thing that you should observe, right? Now when we are evaluating the definite integrals, you will definitely come across this situation, a plus c. Sorry, here you had my plus because the original term has plus, and here you have plus c, and along with this negative sign, this becomes negative c. That means plus c and negative c will get cancelled out, and you remain with this one. Okay, so this is a property of definite integrals. For sure, this arbitrary constant c will vanish. So in other way, when you are evaluating the definite integrals, you don't have to put an arbitrary constant. Okay, only when there is a thing like this without these limits, you should put an arbitrary constant, and otherwise you should not have a arbitrary constant, because that arbitrary constant will be cancelled out within the calculation, right? So this becomes the answer, and you can even simplify it a little further, because ln e is equal to 1 and this is equal to 0. So this is the answer for the given problem. Right, so this is the last problem of the second worksheet. It's again a definite integral, and as the first step, what we can do is we can take the constant out and write the same integral, but with the constant as a multiplication, right? And now when you have the integral of sine 2x, there is a standard format or a standard result for this integral, right? Now that means whenever you have sine ax, the integral of sine ax will be negative cosine ax divided by a, now plus c, right? Now you can even justify this result by differentiating this one. Then you should get the original function inside the integral, right? Because now normally the integral works in the reverse direction of differentiation. So whatever the answer you got as the integral, as the result of the integral, when you differentiate that answer, you should get the initial problem, right? So in that way you can even justify your results, right? So accordingly, now this is a result that you should remember, or else if you think about a suitable antiderivative with the knowledge of differentiation, and if you do the correct calculation, you can easily come up with this result, right? But as we have several such standard results, it's better if you can keep those things in mind. Okay. Right, now as we have this standard result, we just have to substitute it in place of this one. And again, since this is a definite integral, we don't have to use a arbitrary constant. Okay, right, now we have 6, and the antiderivative is cosine 2x evaluated at these 2 points, right, divided by 2. So you have negative 3 cosine pi over 4 plus cosine pi over 6. Then you have negative 3 cosine pi over 4 is root 2 over 2 plus this is root 3 over 2. Right. So this is the answer.